In this video, we will study about the factors on which the resistance depends on. We already know resistance is the obstruction to current flow. We take a piece of wire, you find that it consists of atoms. We take the positive ion and the free electron, positive ion and the free electron, and so on so forth. Let me take till this point here. Now, when an external source of energy, a battery is being connected to this, then you find that the current flows through the conductor. What is the current flow? Again, it is the electrons flowing, conventional current, moving from positive to negative. The battery offers a potential difference, and there is a relation between potential difference and current. By Ohm's law, V is equal to R into I, where R is the resistance. Now, what factors this resistance depends on? I take a piece of wire, for example, let us say copper. We will take one example here, copper, a piece of copper wire. We know that, let me take, for example, 1 meter of copper wire. And I know that it is having positive ions, so it is causing obstruction. I imagine the obstruction to be just like hurdles in a 100-meter relay or any race you take, hurdles. So you have to jump, bounce on each other, move on above each other. Fine. And I take another piece of wire or a track you can imagine, which is 2 meters of length. The distance is increased now. Fine. So all other factors are remaining same. The copper is the material and its area of cross section is same, but now I have got 2 meter length, so naturally I have got 6 hurdles in it. The length is 1 meter and the length is 2 meter. Length is doubled, which will have more resistance, more hurdles, that is, which is having more length. So we can say the resistance is directly proportional to length of the conductor. That is, more the length of the conductor, more the resistance offered or obstruction offered to the current flow. That's the first factor. Let me move on to the second factor. Let us say I take 1 meter wire. Let us say a simple example. In your school, you have 2 gates, let us suppose, right? And this is the school gate. One is a small gate and another is a large gate. Fine. Now, students have to come in to the school, let us suppose. Will you prefer the one, the smaller gate, or will you prefer the larger gate? The convenience is the larger gate, because the more the space area, so you will be able to move freely. That means the resistance is less. More the area, less the resistance. Again, school gate, a smaller gate and a bigger gate, and the bigger gate you move more easily, whereas in the smaller gate you have to hit each other more closely. So naturally the resistance will be more in a narrow gate than the larger gate. Let us now bring the analogy to a wire. Take 1 meter wire, a thin wire, and its area of cross section is something, let us say A1. Fine. And you take another same material, copper, but with double the area of cross section. Fine. Yes, we can say this is A and this is 2A. More the area of cross section, more the flow of electricity will be much better. Resistance is less. So we can say the second reason for that, resistance is inversely proportional to area of cross section. Thickness is more, resistance is less. Thickness is less, resistance is more. So they are inversely proportional. Area increases, the resistance will decrease, and vice versa. So another thing, I have taken all this time only one type of wire, which is copper. Okay, so let me put the equation. R is proportional to length is one equation. R is inversely proportional to area of cross section, equation number 2.